Hello, so this is a revision video for AP Chemistry 8.2, pH and pOH of strong acids and bases. Strong acids completely ionize in aqueous solution. This means that when a strong acid dissolves in water, every molecule donates a proton, H+ ion, to a water molecule, forming hydronium ions, H3O+, and a negative conjugate base ion of the acid is left over. Examples of strong acids include hydrochloric acid, hydrobromic acid, nitric acid, and sulfuric acid. Because the ionization is complete, the concentration of hydronium ions in the solution is equal to the initial concentration of acid that dissolved. This makes it easy and straightforward to calculate the pH of strong acid solutions. For example, if a HCl solution of concentration 0.01 molar, the resulting concentration of H3O+ ions would also be 0.01 molar. The pH would then be pH equals minus log to the base 10 concentration of H3O+ ions, which would be minus log to the base 10 0.01. Given a pH of 2. This works because 1 mole of HCl reacts with 1 mole of H2O to form 1 molecule of H3O+, and 1 mole of Cl- ions left behind. It's important to note here that some acids can donate more than 1 H+ ion when they react. Monoprotic acids form 1 H3O+ ion per acid molecule, such as HCl and HNO3. Diprotic acids form 2 H3O+ ions per acid molecule, such as H2SO4, and triprotic acids can form 3 H3O+ ions per acid molecule, such as H3PO4. To calculate the pH of diprotic and triprotic acid solutions, you need to multiply the concentration of acid at the start by the number of H+ ions each acid can release when they react. Strong bases also dissociate or ionize completely in water to produce hydroxide ions, OH- ions. Group 1 hydroxides like sodium hydroxide and potassium hydroxide release 1 hydroxide ion per formula unit, whilst Group 2 hydroxides like calcium hydroxide and barium hydroxide release 2 hydroxide ions per formula unit. Just like we can use pH equals minus log to the base 10 concentration of H3O+ for strong acids, we can use pOH equals minus log to the base 10 concentration of OH- for strong bases. Again, multiplying the concentration of initial base by the number of OH- ions each formula unit of base releases. Tip here, always check the type of acid and base you are working with in a question. Is it a monoprotic, diprotic, or triprotic acid? And does the base provide more than 1 OH- ion per formula unit? And remember that temperature affects the value of Kw, meaning pH plus pOH equals 14 is only valid at 25 degrees Celsius.